Good morning. Today we are going to start an important topic from part 1, that is third topic in fact, that is trigonometric functions. In this topic there are three parts. In the first part we will be solving trigonometric equations. In the second part we will be discussing properties of triangle, and in the third part we will be discussing inverse trigonometric functions. But as I said, you should know all the uh, important formulae which were done in 11th standard from trigonometry. Now first we discuss what are trigonometric equations. See, an equation which contains trigonometric functions of unknown angles is called a trigonometric equation. For example, I can say sine theta equal to say k1, then cos theta equal to k2, tan theta equal to k3. What are the restrictions on k1 and k2? Both have to lie between -1 and 1, both inclusive. That is, I can say mod of k1 has to be less than or equal to 1. Similarly, mod of k2 has to be less than or equal to 1, and k3 can be any real number. Okay, so these are the examples of trigonometric functions. Now, what do you mean by solution? What do you mean by solution? The value of the unknown angle which satisfies the equation. The value of the unknown angle which satisfies the equation is called solution of the trigonometric equation. For example, can you tell me what is the solution? What is the solution of trigonometric equation sine theta equal to 1 upon root 2? Can you tell me the angle whose sine ratio is 1 by root 2? Yes, pi by 4. So theta equal to pi by 4 is the solution of this. Similarly, if I say that cos theta is nothing but half. Can you tell me what is theta? Yes, theta is nothing but pi by 3. If I say tan theta equal to 1 upon root 3, can you tell me the solution of this? Can you tell me the theta which will satisfy this equation? Yes, you guessed it right. It is pi by 6, that is 30 degree. Okay. So the trigonometric functions, as we know that they are periodic and their values repeat over a certain interval, which we call as fundamental period. Therefore, the trigonometric equations have infinite number of solutions. I repeat, trigonometric equations have infinite number of solutions. See, in this case, I said theta is pi by 4, but there are infinitely many angles who have the same sine ratio 1 by root 2, and therefore this equation has in fact infinitely many solutions. Actually, there are two types of solutions. The first is principal solution and the second is general solution. We will discuss both and then we will solve few sums based on principal solution, and then we will discuss the second part. The first one is principal solution. Listen to me carefully. The solution of a trigonometric equation of an unknown angle x. The solution of a trigonometric equation of an unknown angle x where 0 less than or equal to x less than 2 pi are called its principal solution. For example, let me explain first. If you have any difficulty, you can ask me later on. Sin x equal to root 3 by 2. Now tell me what are the principal solutions. Tell me the angles. There will be two angles always. Tell me two angles lying between 0 and 2 pi. 0 is included, 2 pi is not, for which sine ratio is root 3 by 2. Yes, correct. Pi by 3. That is why I say that you should know allied angles also. So can you tell me the other angle? Yes, 2 pi by 3 also. Why? See, sine of 180 minus theta is also sine theta. So these are the two angles. Is that clear? So we say that for sin x equal to root 3 by 2, pi by 3 and 2 pi by 3 are principal solution. Now you have to tell me whether number of principal solutions is finite or not. The answer is not necessarily. Why? Because if I say that sine square theta plus cos square theta equal to 1, what can we say about this? Hmm? See, here number of principal solutions is infinite. Why? Because for every theta lying between 0 and 2 pi, this equation is satisfied. So usually for equation like sin x equal to or cos x equal to, number of principal solutions is finite, it is 2. But for an equation, or you call this as an identity rather, number of principal solutions is infinite. Now we discuss general solution. The solutions of a trigonometric equation which are generalized by using the periodicity are called general solution. For example, for the equation sin x equal to root 3 by 2, sin x equal to root 3 by 2, we know that for angle pi by 3, then 2 pi by 3, then another angle 7 pi by 3. For all these angles, sine ratio is the same. See, we know that sine of 180 minus theta is sine theta. Sine of 360 plus theta is also sine theta. Is that clear? So all these are general solutions. So clearly, number of general solutions is always infinite. Now we are going to use one notation. The general solution of any trigonometric equation, we will use small n as an integer. That is, we will always say small n belongs to set of z. What do you mean by z? Z means set of integers. Is that clear? I think I should repeat the first part once again. Before that, let me tell you that before trigonometric equations, we have discussed equations involving variables x, y, z, right? Such equations are called as algebraic equations. For example, x plus 4 equal to 0 is an algebraic equation whose solution is x equal to minus 4 and so on, right? Like a trigonometric equation, algebraic equation also can have infinite solutions. For example, x plus y equal to 0. This equation has infinite solutions. In fact, this equation represents a line, and every point on the line, coordinates of every point on the line is the solution of this equation. But in this topic, we are interested in trigonometric equation. We were discussing about types of solutions. The first is principal solution. I'll explain this once again. The solutions of a trigonometric equations of an unknown angle x where 0 less than or equal to x less than 2 pi are called principal solution. If I say sin x equal to root 3 by 2, tell me the angle lying between 0 and 2 pi, 0 included, 2 pi excluded, for which sine ratio is root 3 by 2. First angle is clearly 60 degrees, that is pi by 3. Now you should know allied angles. Sine of 180 minus theta is also sine theta. So 120 degrees is another solution. Now many students think that number of solutions is 2 only. Yes, in most of the cases it is restricted to 2. But for sine square theta plus cos square theta equal to 1, which is an identity, for every theta lying between 0 to 2 pi, this is satisfied, and therefore in this case we say that number of principal solutions is infinite. Is that clear? Exercise 3.1, find question 1, find the principal solution of the following equations. Number 1, cos theta is half. See, this will be asked for 2 marks. Presentation is important. You have to find the smallest angle for which cos theta is half, that is pi by 3. You have to express angle in radian. So pi by 3, cos pi by 3 is half. Now cos of 2 pi minus theta is cos theta. So cos pi by 3 is nothing but cos of 2 pi minus pi by 3. LCM is 3. So 6 pi minus pi, that is 5 pi. This means these angles pi by 3 and 5 pi by 3. For them, cosine ratio is half. You have to say that these two belong to the required domain, semi-open interval, right? So the principal solutions are pi by 3 and 5 pi by 3. Second is actually similar to the first one. The only thing is sec is given. For that sake, you have to consider the reciprocal. Sec theta 2 by root 3. So it is cos theta root 3 by 2. But cos pi by 6 is root 3 by 2. And cos of 2 pi minus theta is cos theta. So cos pi by 6 is same as cos of 2 pi minus pi by 6. That is cos of 11 pi by 6. Now both pi by 6 and 11 pi by 6 belong to which interval? Semi-open interval 0 to pi. So these are the principal solutions. Third one, cot theta is root 3. So what is tan theta? 1 by root 3. But tan pi by 6 is 1 by root 3. Also, you have to mention that tan of pi plus theta is tan theta. So tan pi by 6 is the same as tan of pi plus pi by 6, that is 7 pi by 6. Now both pi by 6 and 7 pi by 6 belong to the semi-open interval. So these are the principal solutions. Now the next one is for homework. This is the answer. Now you should know these allied angle formulae. Sine of pi plus theta is minus sine theta. Tan of pi minus theta is minus tan theta. Cos of pi minus theta is nothing but minus cos theta. Actually, sine of 2 pi minus theta is also minus sine theta. But we have to consider the smallest angle. That is why we use this. I'll explain how. So second question, find the principal solutions of the following equations. Let me explain first. First one, sine theta is minus half. Okay. Now I will say sine pi by 6. Let me explain first. Sine pi by 6 is nothing but half, and sine of pi plus theta is nothing but minus sine theta. Is nothing but minus sine theta. Okay. After this, now you can start writing. You can start writing. Okay. Actually, we have to write one more. Along with sine of pi plus theta equal to minus sine theta, sine of 2 pi minus theta is minus sine theta. So sine of pi plus pi by 6 means sine of 7 pi by 6 is minus half. Sine of 2 pi minus pi by 6, that is sine of 11 pi by 6, is also minus half. Now both these angles belong to this interval. So these are the principal solutions. So in fact, just a minute. Here you have to write sine. You already written sine of pi plus theta is minus sine theta. After this, you have to say sine of 2 pi minus theta is also minus sine theta. Okay. Now, tan of pi minus theta is minus tan theta. Then tan of 2 pi minus theta is also minus tan theta. Cos of pi minus theta is minus cos theta. Similarly, cos of pi plus theta is also minus cos theta. See, we have done this in 11th standard only. Second, tan theta is minus 1. See, tan pi by 4 is 1. So tan theta equal to minus 1 can be written as minus tan pi by 4. But tan of pi minus theta is minus tan theta. And tan of 2 pi minus theta is again minus tan theta. So minus tan pi by 4 is tan of pi minus pi by 4. That is tan of 3 pi by 4. Minus tan pi by 4 is tan of 2 pi minus pi by 4. That is tan of 7 pi by 4. Now both these angles 3 pi by 4 and 7 pi by 4 belong to this semi-open interval. So these are the principal solutions. Now third is similar to the first. So this is for homework. The only thing is they have given cosec. So what is cosec from this? Minus 2 by root 3. So it will be sine minus root 3 by 2. So this is the answer. Now general solution. I will again repeat the definition. The solutions of a trigonometric equation which are generalized by using its periodicity are called its general solution. Now we discuss general solution for three equations. The first one is sine theta equal to 0. See, what is sine 0? 0. What is sine pi? 0. Now we are interested in general solution and not principal. So sine 3 pi 0, sine 4 pi 0 and so on. So in general, sine of 2n pi plus pi is nothing but sine pi, right? So can I say that sine theta equal to 0 has general solution? Just let me explain. Has general solution theta equal to n pi. And what is n? Initially only I have told you that n is an integer. So assign any integral value to n, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. You will notice that sine theta for that case is always 0. And therefore, what is the general solution of sine theta equal to 0? It is theta equal to n pi, where n is an integer. Secondly, cos theta equal to 0. Cos theta equal to 0. Now you know that cos pi by 2 is 0. See, basic trigonometry. Sin theta is always sin theta is nothing but y. Cos theta is nothing but x. Now when is y coordinate 0? When point lies on x axis, and that is why 0 degree, pi, 2 pi, 3 pi, 4 pi. So for all these angles, sine ratio is 0. Similarly, cos theta is y. Now cos theta is 0. I'm sorry, cos theta is x. So cos theta is 0 means x is 0. Now if a point lies on x axis, if a point lies on which axis? What I'm doing? I'm sorry. See, here only I'll write cos theta, I'm sorry, it is nothing but x, and sine theta is nothing but y. Okay. From the beginning, sine theta is 0 means y is 0, and y is 0 if point lies on x axis. So for the angles, for these angles, 0 degree, pi, 2 pi, 3 pi, 4 pi, all these angles, sine ratio is 0. So the general solution is theta equal to n pi. Second, cos theta equal to 0. But cos theta is x. So if x is 0, now x is 0 for which angles? If a point lies on y-axis, x coordinate is 0. So for pi by 2, right? For pi by 2, cosine ratio will be 0. 3 pi by 2, again cosine ratio will be 0. Now you will notice that pi by 2, 3 pi by 2 are all odd integral multiples of pi by 2. And therefore, here I will say the general solution is theta is 2n plus 1 pi by 2, where n is an integer. See, if n is an integer, 2n is always even and 2n plus 1 is always odd. That is why I am saying for odd integral multiples of pi by 2, for those angles, cosine ratio has to be 0. I hope this is clear to you. So for sine theta equal to 0, general solution is theta equal to n pi. For cos theta equal to 0, general solution is theta equal to 2n plus 1 pi by 2. Of course, n is an integer. Now tan theta is 0. See, tan theta is 0 when sin theta is 0 and cos theta is non-zero. So tan theta equal to 0 has the same general solution as that of sin theta equal to 0. I hope you are getting this. So tan theta equal to 0 has general solution theta equal to n pi, n belongs to z. Is that clear? So this is about general solution of these three equations. Sin theta equal to 0, cos theta equal to 0, tan theta equal to 0. Next part, in the next theorem, we will be discussing sin theta equal to, say, sin alpha. See, sin theta need not be 0. Sin theta can be minus half also. So in that case, we are interested in finding general solution. So we will consider the cases sin theta equal to sin alpha, cos theta equal to cos alpha, tan theta equal to tan alpha. Now we discuss general solution of which equation? Sin theta equal to sin alpha. The general solution of sin theta equal to sin alpha is what? Theta equal to n pi plus minus 1 raised to n alpha, where n is an integer. Let me tell you the proof also. This is not at all difficult. See, sin theta is sin alpha, right? So can I say that sin theta minus sin alpha equal to 0? Yes, I can. Now what is sin A minus sin B? It is 2 cos of A plus B by 2 into sine of A minus B by 2. Is this clear? Now, the product is 0. So I can say that either this equal to 0 or this equal to 0. I'm writing this directly. Now, cosine is 0. What is the solution for this? I can say, from this I can say that theta plus alpha by 2. Cosine ratio of this angle is 0. So this has to be odd integral multiple of pi by 2. Instead of n, I have used another uh, integer p. Okay. Similarly, sine of angle, sine of this angle is nothing but 0. So this has to be what? P pi, where p is nothing but an integer. Now rearrange the terms. So that gives me theta plus alpha equal to what? 2p plus 1 into pi. Theta minus alpha equal to 2p pi. That is, let me explain first. Theta is nothing but 2p plus 1 pi minus alpha. Theta is 2p pi plus alpha. Now observe this. 2p plus 1 is definitely an odd integer. So for an odd integer, minus alpha. 2p is always an even integer, for this plus alpha, and therefore I can combine these two. And say that theta is nothing but n pi plus minus 1 raised to n alpha, where n is an integer. You can verify. Suppose n is odd, then minus 1 raised to odd is minus 1. Yes, it is minus alpha. Suppose n is even, minus 1 raised to even is plus 1. Yes, for even it is plus alpha. I hope this is clear to you. And therefore, the general solution of sin theta equal to sin alpha is what? Theta equal to n pi plus minus 1 raised to n alpha, where n is an integer. Now the next one, the general solution of cos theta equal to cos alpha is theta equal to 2n pi plus minus alpha, where n is an integer. Proof is on similar lines. Cos theta is cos alpha. So cos theta minus cos alpha equal to 0. What is cos A minus cos B? Minus 2 sine of A plus B by 2 into sine of A minus B by 2. So either sine of theta plus alpha by 2 is 0 or sine of theta minus alpha by 2 is 0. But what is the general solution for sine of any angle equal to 0? That angle equal to n pi. So theta plus alpha by 2 is n pi or theta minus alpha by 2 is n pi. That is theta plus alpha equal to 2n pi, theta minus alpha equal to 2n pi. That is theta equal to 2n pi minus alpha or theta equal to 2n pi plus alpha. Now combine them to get theta equal to, see the cursor, theta equal to 2n pi plus minus alpha. That doesn't mean that plus alpha minus alpha gets cancelled. No, these are clubbed. First is 2n pi plus alpha and then 2n pi minus alpha, where n is an integer. Now next one, if theta and alpha are not multiples of pi by 2, then general solution of tan theta equal to tan alpha is theta equal to n pi plus alpha, n is an integer. See, why to say that not multiple of pi by 2? Because in that case tan theta is not defined. Okay, tan theta is tan alpha. But what is tan? Sin by cos. So sin theta upon cos theta equal to sin alpha upon cos alpha. Cross multiply and rearrange the terms. So sin theta cos alpha equal to cos theta sin alpha. That is sin theta cos alpha minus cos theta sin alpha equal to 0. But this is expansion of sin of theta minus alpha. Is that clear? So theta minus alpha is nothing but n pi plus minus 1 raised to n into 0, because sine 0 is 0. This gives me theta minus alpha equal to n pi. That is theta equal to n pi plus alpha, where n is an integer. So we have covered all the three: sine theta equal to sine alpha, cos theta equal to cos alpha, and tan theta equal to tan alpha. Now last and important part, the general solution of sine square theta equal to sine square alpha is theta equal to n pi plus minus alpha, n is an integer. Same for cos square theta equal to cos square alpha and tan square theta equal to tan square alpha. Let me explain the proof. Sine square theta is sine square alpha. So 2 sine square theta will be 2 sine square alpha. Now if I subtract, or if I say multiply by minus 1 and then add 1, then it becomes 1 minus 2 sine square alpha. So I can directly write cos 2 alpha. But here they have written that what is 2 sine square theta? 1 minus cos 2 theta. 2 sine square alpha, 1 minus cos 2 alpha. Rearrange the terms to get cos 2 theta equal to cos 2 alpha. So what is 2 theta? We have already solved an equation cos theta equal to cos alpha. Using that, 2 theta is nothing but 2n pi plus minus 2 alpha, where n is an integer. See, this is the reason. Before discussing this proof, we have already proved this, that cos theta equal to cos alpha has general solution theta equal to 2n pi plus minus alpha. So here it is 2 theta. That is why I have written 2 theta equal to 2n pi plus minus 2 alpha, where n is an integer, right? So theta equal to ultimately n pi plus minus alpha, n is an integer. Hence the general solution of sine square theta equal to sine square alpha is theta equal to n pi plus minus alpha, n is an integer. For cos square theta equal to cos square alpha, same logic. 2 cos square theta is 2 cos square alpha. Add 1 to both the sides. But what is 1 plus cos 2 theta? Cos 2 theta. I'm sorry, this should be 1 plus, what is this? They have said that 1 plus cos 2 theta. Okay. They haven't added that. They have used the result cos 2 theta is nothing but 2 cos square theta minus 1. So what is 2 cos square theta? 1 plus cos theta. No problem. Otherwise, I would have suggested that subtract 1 from both the sides and then for 2 cos square theta minus 1 directly write cos 2 theta. Same thing. So cos 2 theta is cos 2 alpha. So 2 theta is 2 n pi plus minus 2 alpha. Divide by 2 to get theta equal to n pi plus minus alpha, where n is an integer. So what is the general solution of cos square theta equal to cos square alpha? Same. Theta equal to n pi plus minus alpha. N is an integer. Tan square theta equal to tan square alpha. Tan square theta can be written as tan square theta upon 1 equal to tan square alpha upon 1, componendo dividendo and then invertendo. You get this 1 minus tan square theta upon 1 plus tan square theta equal to 1 minus tan square upon 1 plus tan square. But note that this is cos 2 theta, this is cos 2 alpha. Same thing again. 2 theta is 2 n pi plus minus 2 alpha, n is an integer. Divide by 2 to get theta equal to n pi plus minus alpha, n is an integer. Hence, the general solution of tan square theta equal to tan square alpha is theta equal to n pi plus minus alpha, n is an integer. And therefore, the general solution of all these three, sin square theta equal to sin square alpha, cos square theta equal to cos square alpha, tan square theta equal to tan square alpha is what? Theta equal to n pi plus minus alpha, where n is an integer. Basically, you have to remember these many things. Equation general solution. Sin theta equal to 0. Theta is n pi. Now I will not say n is an integer because n will be an integer. Cos theta equal to 0. Theta equal to 2n plus 1 pi by 2. Tan theta equal to 0. Theta equal to n pi. Sin theta equal to sin alpha. Theta equal to n pi plus minus 1 raised to n alpha. Cos theta equal to cos alpha. Theta equal to 2n pi plus minus alpha. Tan theta equal to tan alpha. Theta equal to n pi plus alpha. And for sin square theta equal to sin square alpha, cos square theta equal to cos square alpha, tan square theta equal to tan square alpha. Common general solution, theta equal to n pi plus minus alpha. Exercise 3.1. Actually, this is third question. Find the general solutions of the following equations. First part, sin theta is half. Now when I say sin theta is half, I have to consider theta is pi by 6. You may say that sin of pi minus theta is also sin theta. Yes, I agree. But you have to consider smallest positive angle. And that is why I have chosen pi by 6. Now what is the general solution of sin theta equal to sin alpha? Theta equal to n pi plus minus 1 raised to n alpha. N is an integer. So for this equation, sin theta equal to half, theta equal to n pi plus minus 1 raised to n into pi by 6, where n is an integer. Second, cos theta is root 3 by 2. The smallest positive angle for cosine ratio is root 3 by 2 is 30 degrees. That is pi by 6. Now cos theta equal to cos alpha has general solution theta equal to 2n pi plus minus alpha. So here alpha is pi by 6. So what is the general solution? 2n pi plus minus pi by 6. N is an integer. See, you have to write this. Third is similar for homework. Tan theta equal to 1 by root 3. So theta is what? N pi plus pi by 6. N is an integer. For fourth part, you have to be careful. See, cot theta is 0. That clearly shows that tangent ratio is not defined. Tan theta doesn't exist. Now, can you tell me the angle for which cotangent ratio is 0? Pi by 2, because tan pi by 2 is not defined. So, cot pi by 2 is cos pi by 2, which is 0, upon sin by 2, which is 1, 0 upon 1 equal to 0. And that is why I have written, so tan theta is tan pi by 2. Now what is the general solution of tan theta equal to tan alpha, theta equal to n pi plus alpha. And that is why I have written General solution for cot theta equal to 0 is n pi plus pi by 2. You can check this. Suppose you put n equal to 2. What is cot of 2 pi plus pi by 2? It is cot pi by 2. Is cot pi by 2 0? Yes, it is. Second, cosec theta is minus root 2. So what is sine theta? Minus 1 by root 2. Now sine pi by 4 is 1 by root 2, right? After this, we have to say minus sine theta is sine of pi plus theta. You may also argue sine of 2 pi minus theta is also minus sine theta. I agree. But we have to consider smallest possible angle. Is that clear? And that is why I have written minus sine theta is sine of pi plus theta. Now theta is pi by 4 and therefore I can say now given equation is sine theta equal to sine of what? Pi plus pi by 4 is 5 pi by 4. Of course, we have to say the general solution of sine theta equal to sine alpha is theta equal to n pi plus minus 1 raised to n alpha. I have directly written value of alpha which is pi by 4. So what is the answer here? Theta equal to general solution theta equal to n pi plus minus 1 raised to n 5 pi by 4 where n is an integer. It is better if you put this in bracket. Right. Now one more sum and then we'll stop. See, tan theta is minus 1, right? But tan pi by 4 is 1. So minus 1 is nothing but minus tan pi by 4. Now minus tan theta is tan of pi minus theta. So this becomes tan of pi minus pi by 4, that is tan 3 pi by 4. In short, tan theta equal to minus 1 becomes tan theta equal to tan 3 pi by 4. Now what is the general solution of tan theta equal to tan alpha? It is theta equal to n pi plus alpha. Here alpha is 3 pi by 4. So the general solution is theta equal to n pi plus 3 pi by 4. N is an integer. So that's it for today.